Hello today, guys. Today we're going to be talking about section 6-3, and today we're going to be looking over how to make comparative inferences about population. So we'll be comparing two different sets of things, looking at different charts and graphs. So we're going to start with example 1. We're using box and whisker plots to compare populations, and I'm pretty certain you guys have looked at these plots before. We're not going to talk so much about creating them, but more of looking at them and just knowing what they mean. So our first question says, Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. So what they want to know is, what can Finn notice about the time spent on the homework? So he's going to end up making an inference. So right here, we're looking at a little chart, and I'm going to put a little arrow next to it. We're looking at this little chart. So in each little box, if we look at the top here where it says Finn, he's got all these students and the number of hours they spend each week on homework. And notice that it goes up in terms of how much. So this student spent 1 hour, this student spent 4 hours, etc. At Jonah's school here on the bottom, same thing, 1, 5, 5, etc. So each one of these numbers represents a student and how long they spend on homework each week. So in order to make a good inference, we're going to use a box and whisker chart to display this information. So here goes step 1. We're going to display the two data sets, and we would call Finn's numbers a data set. We would call Jonah's numbers a data set in a box plot. So notice we have a little number line from 0 hours to 11. Why? Because 11 is the most, and obviously we always want to start at 0. So this first box and whisker plot, we have our box here, and these things are whiskers that come out here. Okay. If we look at Finn's data set, it starts at 1, as his data does, and it goes to 11, which his data does. If we look at Jonah's, it's the same thing. Starts at 1, ends at 11. Now, what you might see is that these are different on each one. Okay. So if we look at this top box here, it says this box is between 3.5 and 6.5. So what does he mean by that? So this line here is at 3.5. And this line here is at 6.5. Now that box in the middle, that kind of tells us where most of the data, the middle of the data is at. And this line that runs right down the middle, that's our median or middle point of our data. So we can do the same thing when we look at Jonah's data. We have our outliers here, our whiskers, and his box settles between 5.5 and 8. As you can see, 5.5 and 8. And his median is at 7. So it's a little bit different than what Finn's is. Okay, so we can see how their groups of data compare. Finn's median is at 5, so the middle point in his data is at 5. Jonah's middle point is at 7. So step 2, we're going to use the box plot to compare the two data sets. So we're just going to compare them. So going back to our question, what can Finn notice about the time spent on homework? Now, you're going to see on these notes and our next set of notes that I've written kind of information about box and whisker plots and how we look at data, right? In these blue fonts. So this says in a box and whisker plot, the data is split right down the middle, right? So we take the data, split it down the middle, and that is our median. So that's a word that we need to know, median or middle. So what can Finn notice about the time spent on homework? Well, he can notice a couple things. The first thing he can notice is that the line for the median of Jonah's data is to the right of the line of the median of Finn's data, right? As you can see here, Jonah's data is here. Finn's data is there. So Finn can say, I'm going to highlight this in purple, that the median of Jonah's data set is greater. Oh, that's a little bit easier to see. Okay. So the median is greater for Jonah. Okay. So something else he could say then, the box for Finn's data set is longer than the box for Jonah's data set. So I'm going to try and make that a little bit clearer for us. So if I draw a line here, we can see that that line is bigger than what this box is. So Jonah's or Finn's box is greater than Jonah's box. So that box, that tells us something about how spread out the data is. So we can say that since Finn's data set, this box is longer than the box for Jonah's data set, we can say that Finn's data is more spread out or has greater variability. So that's another word that we need to know. I wrote that in bold. We need to know that. So going down this bullet point, some vocab we need to know. Variability, or the spread of the data, refers to how spread out the data is that has been collected. So basically the range, like we look back at our graph, we've got 1 all the way up to 11. That's how spread out the data is. The data that has a greater IQR or interquartile range. Now that's a big word, and all that means is how big the box is. The range between this point and that point. That has a greater variability. So the bigger this IQR, this interquartile range, the greater variability. So in terms of a box and whisker plot above, the bigger the box, the more variable it is. And this is something maybe that is easier to remember. The bigger the box, the more variable the data is, the more spread out. Okay. So keywords: median, that's the middle of our box, and variability, how spread out, how big is that box. Okay. Next page. Example 2. We're going to draw some inferences using the median, or the middle, and the interquartile range. Okay. So it says Finn and Jonah analyze the measures of center, and we're going to get to this word here soon. And the variability, so another keyword, how spread out the data is, of the data they collected. Do these measures support Finn's assessment of the two data sets? So if we go back to 1, we said that Finn's data had greater variability, and he said that the median of Jonah's set is greater. So let's go back. So we want to know, do these measures, so using a median and measures of center, which we will get into, does it support Finn's assessment of the two data sets? So in the blue, I wrote a couple things here. It says, after finding the median in a box and whisker plot, we take those two halves. Once we split something down the middle, we take those two halves, and then we split those two things down the middle, right? And we get what is a first and third quartile. So basically the middle of both halves. Now those first and third quartiles, they make the outside lines of the box. So if I say look at Finn's data here, I'm going to use a little blue line here. This first quartile of Finn's data would be right here. The third quartile for Finn's data would be right here. And the median, that's right here. So first quartile, median, third quartile. They form this box. So those are the numbers we use to form this box. Now the median can also be called the second quartile, first, second, third, but normally we just call it the median. And lastly, this interquartile range is basically the difference between this third and this first quartile. Now we're not going to be constructing any box and whisker plots, but those are kind of things we need to know, and we're going to go over those again at the end. So when we look at these things, and we look at a box and whisker plot, basically all that means is this arm here, since we split this into fourths, this is half the data, or this is a fourth of the data. This is a fourth of the data. That's a fourth, and that's a fourth. So 25, 25, 25, 25. So this box represents 50%, and each one of these whiskers represents 50% when they're put together. Okay. So we're going to look at this little table here to the right. We have our quartiles, we have our medians, and we have an interquartile range. Remember, we said the interquartile range stood for how spread out the data is. We can notice Finn's data, when we subtract these, so 6.5 minus 3.5 is 3. 8 minus 5.5 is 2.5. And we see that this interquartile range based on our subtraction is bigger. Okay, so by finding this interquartile range, comparing the first and third quartiles, we can say this: the median of Jonah's data set is greater, right? 3 is greater than 2.5. So the students at Jonah's school generally spend more hours on homework. So that's an inference, a valid inference that we can make. Okay, something else. That interquartile range of Finn's data, which was 3, that means there's a greater variability, or the spread, or more apt to our question, there's a greater difference in the number of hours students in Finn's school spend on homework. So looking back at this, we find an interquartile range by taking the difference between this line to the right and this line to the left, and you'll always have a little number line right below it. So if we follow this down, there and there, you take those two numbers, and sometimes you kind of have to estimate, and you just subtract them, and that's how you find your interquartile range. Okay. All right. Moving on. Last example, and all this stuff we're going to go over again at the end of this lesson. Okay. Example 3. We're going to draw some more inferences using measures of center and variability. So it says Ms. Bunsen had students grow the same type of plant in 2 different rooms. To test the growing conditions, right? So she wanted to see how something grew in one room as compared to another room. That'd be like if I was growing something in my room and then you guys were growing something in the science class. The box plots show the heights of all the plants after 3 weeks. How do the 2 populations compare? Okay, so the populations here would be all of the plants grown in each room. What inferences can be drawn? So we want to answer those 2 things. How do the 2 populations compare? And secondarily, what inferences can we make from that data? So here is, I'm going to highlight this one in yellow. So here's one box plot. Here is another box plot. And we're just going to see how they compare. Now, when I look at this, we've got this box here. That red line I drew is our interquartile range. And let me redraw that, make it a little straighter. Okay. And here's an interquartile range for this box plot. Now, that doesn't tell us much there, but we can also look at their medians. Now, here's a median and there's a median. Those look almost exactly the same. So these 2 things, medians are the same, about 12. But here's a first quartile for this guy, for room 7D, and there's a first quartile for that one. So those are different, along with their third quartiles. Those are also different. So what I'm going to do, I'm going to drag this little line. I'm going to see if it's the same length. It is. So that means they have the same amount of variability. Their IQR is the same. So let's see what's written in these different boxes. So number 1, the median heights are the same. So the IQR for 7D are between 6 and 14. IQR of 6. Here, they're 10 and 16. From first to third, IQR of 6. So it's just an inference that we can make here based on what we're looking at. We can say, while the median heights are the same, so that's number 1, median heights are the same. The plants in room 7G are generally taller. Now, why can we say that? Okay, the reason we can say that is, notice that this box is farther ahead than this top box here. So more of the plants are taller in room 7G than they are in 7D. So our main inference we can make, we can infer that the growing conditions in room 7G are more favorable to plant growth in 7D. So basically all we're doing with this lesson is looking at 2 sets of data and comparing. How do the medians compare, or the middle number? How spread out is the information or the data? That's called our interquartile range. That measures variability. So in review, let's go to this one last page. Okay, looking at box plots, right? These are something that we need to look at, right? This box, that's our median. This first line, that's our lower quartile or upper quartile, also called the first and the third. And the box shows the interquartile range. Now, I wrote down some definitions here in these red lines. So the median is the middle number, right? That's always this line here. So median, that's this line right here. Okay, the first quartile, that's the middle number of the first half of data, right? I'll use a green line for that. First quartile, also called the lower quartile. Okay, the third quartile then, that's that last line in the box, the outside right of the box. So let's use blue for that. The third quartile is the middle number of the second half of data, also called the upper quartile. Now our box, then that is made up of the first, the median, and the third quartile. So all 3 of these lines, first quartile, median, third quartile, they make up our box. I'm just going to draw that in here. Let's use a black line for this. So these things that make our box. And we need to remember that all this information, right, that makes up 50% of our data. And this is what we use mainly to compare all of our stuff. This little box. How do the boxes compare? Now the whiskers, we haven't talked a lot about the whiskers of the box. These are the lines. So I'll use, what can I use? How about this yellow? There's a whisker, and generally they have like a little number on this, or a little line on the side of them. Whiskers. Okay. Now, what these whiskers tell us, these make up the lowest number and the highest number in the data set, right? And we call these things outliers. So that's saying if you collected data and you had one number that was so far off of everything else, okay? And say, I wanted to take an average of what you guys scored on a quiz, and everyone was in around 70%, and someone say they didn't do it and they got a 0%, right? That would be called an outlier. That would throw off our data. So these are the outliers. And when we compare data using a box and whisker plot, we don't really want to look at those things. We just want to look at what's in our box, okay? Now, the last part of this is the IQR, the interquartile range. Okay, remember the interquartile range, that is the difference between the third and first quartiles. And that measures the variability. Remember, that's how wide the box is, okay? And that tells you how spread out the data is. So the bigger the box, the greater the variability. If the box is really narrow and short, then all the numbers are kind of squeezed into each other. Okay? So there we go. That's lesson 6-3. And all we did today was looking at different data sets and comparing them.